Hello everyone, this is KP the Math G, at it for 2 times in one day. This will probably be the last one today, but I just really want to do a couple more, probably not more than 3. If we count this one, it would probably be 3 more videos on this kind of thing, but the last 2 are going to be maybe a line and a curve intersecting, or 2 curves intersecting, or whatever. I want to do that before we get off of this. And after that, I want to get on a few of the problems that are in or on the AP, on prior AP exams that date all the way back from 1998 till the present. So I'm going to be looking and searching. I already have one available ready to go, but I just want to get a few of those. If you're just taking regular calculus, I'm sure this will help you as well. So anyway, just tune in, keep tuning in, and just watch my videos, and I'll show you a few things that you can do on these tests and everything. This is again another revolving. It's a volume of revolution is what the title is, and it is done by the washer method. If you read down here, you'll see that we're going to revolve the area, this area here, bounded by y equals x plus 2, bounded by y equals 2, and x equals 3. We're going to revolve that about x equals 5. Okay, I want to erase this because I need to do my I sub interval right there. I didn't think about that before I put it up there. Okay, I like to do this when I'm doing an interval and I can see it. Okay, I see what's going on. Since we're going this way now instead of this way, remember, if you go this way you have to do everything in terms of x. If you go this way perpendicular to the y-axis, now you've got to solve for x so you can do everything in terms of y. Alright, so we really want this piece here. Alright, we want this. Alright, we want this to go here like this. We want this. This is really what we want. This is, remember, we want to revolve it about this line, so you start from the line, go out to the line or the curve that you're under consideration, okay, and you want to revolve that. Now this distance is going to be from here to here. Alright, this distance from here to here, okay, here to here is big R. Okay, I don't really need to, I don't want to muddle this up. This distance from here to here is big R, okay? That's our big radius. Remember, then this distance from here to here is your little radius. Remember, we are going to have a hole. This is the hole. Okay, if you have a hole, you're going to have a radius squared minus a radius squared. Now let's figure out how long this big R is. I know how long little r is, don't you? This goes from 3 to 5, so we know that little r is equal to 2. We know that. We've already got that. So we know from just by looking at that, that is going to be 2 units. Okay, since this is x equals 3 and here's x equals 5, that from 3 to 5 is 2 units. Now how far is this? Well, here's what I like to do. Let me get a different color. I like to extend this all the way over, and I'm doing it for a purpose. Okay, I want to actually probably dot this. This is not part of the part where, okay, alright. Alright, I just want that little part right there. I want to know how far is it from, well, let's go ahead and dot line. How far is that green section? Well, when we did other videos and it was going vertically upward, that distance was y, wasn't it? On previous videos, you'll find that that distance was y. Now, how far is this? If this going up and down was y, how far is this going across? From 0 to right here, this distance here is x, isn't it? That distance right there is x. How far is that from, let's say, this part right here? Okay, we know that this entire distance is 5, isn't it? This distance from here to here is 5, isn't it? All the way from here. That's why I like to do this. Alright, so how long is our distance from here to here then? Well, if this total distance is 5 and this little distance is x, let's say x is equal to, I don't know, 1. It looks like it is. It looks like it's in line 1. Let's say x is 1. Then if this is 5, then this distance is 5 minus that 1, which is 4, isn't it? But since we don't know how far out this is, we can't really ascribe a number to it. So we just got to use x. So this distance here is 5, right from here to here, from here to here. This distance here is 5 minus x. Okay? The rest of it is 5 minus this x is the rest of this. That's how you have to view that. Okay? Alright. We could have said, well, this distance right here is 3. Alright? And so that makes this distance 3 minus x. But we know this distance is 2. So 3 plus 2 is 5. So then 5 minus x. So if we know that this distance is 3 from here to here, from here to here is 3, then this right here is 3 minus x. This little portion inside here is 3 minus x. But really, the easiest way to show you this is not doing that. Okay? The easiest way that I can find is, and I've studied this for some time, is to just say, well, this distance is 5 and this distance is x. That makes this rest of this distance, which is big R, by the way, 5 minus x. So big R is 5 minus x. Little r, we know, is 2, don't we? So now I can set this up. Remember pi r squared, so pi. Alright, now we'll worry about what the limits of integration are going to be in just a moment. You probably already know what they are, but I will tell you in case you're having trouble with that. Alright, we're saying 5 minus x. And for the time being, I'm going to write this down squared. Remember, that's a big radius squared. Now remember, we're subtracting off the circle, which is that distance there, which is 2 squared. Alright, but now that is going to be, remember, this is not delta x, this is delta y. Okay, remember, when we're going perpendicular to the x-axis is delta x, perpendicular to the y-axis is delta y. Alright, now dy here. I don't want it, I need to figure out what x is. I have, my equation says that this equation here is y is equal to x plus 2. Since I need x right here, I need to find out what x is right here. Okay? Alright, so let's minus 2 on both sides. So that makes sense. Alright, if y is equal to x plus 2, then x is equal to y minus 2 is x. That's what I'm wanting here, because that's what I said. This is x. Well, what is x? It is y minus 2. So you have to do that. You have to remember that when you are when you're dealing with something perpendicular to the y-axis, then you must solve it in terms of y. Okay, it has to be in terms of y. Alright, well, I'm just going to substitute that y minus 2 in place of x. Oh, okay, y minus 2. So x is y minus 2. Alright. Erase this. I have a feeling I'm going to need all of this board and then some. Alright, so now this equals pi times, alright, we got to get our integration. Okay, so let's see, where are we going from? Notice that if you're dealing with y now and delta y and so on, you must pick the y values. This is the low limit, and this is, you cannot say from 0 to 3. You're not going, your isolate interval is not going this way. Your isolate interval is going this way, up and down. Alright, so up and down, the lowest it can go is to 2, and the highest it can go is up to 5. So you must pick the y values. That is important. I used to miss that and miss it, and oh my goodness, just yank what little hair I've got out of my head trying to figure that out. That isolate interval can scoot up and down this way. So the lowest it can go on the y is 2, and the highest it can go on the y is 5. So we are getting it correct. It is from 2 to 5. Now 5 minus x is 5 minus, alright, x is y minus 2. Use parentheses. Little things like that parentheses. If you leave that off, woo, you have made a blunder. That's one thing for me. I play chess sometimes, and that's one thing for me to make a chess blunder. And believe me, I make plenty of them. But do not make a blunder here, especially when you know you're going to go 15 miles to get to your final answer. Use parentheses. Okay, minus 2 squared, which is 4. By the way, this is 5 minus y minus 2 squared minus 4, already is squared 2. Alright, now that, all of that, dy times dy. Okay. Now, let's keep going. Okay, we're going to need all of this room here. Let's try to squeeze it in. Equals. Alright, we are going pi. Well, let's leave off the equal sign. I need all the room I could take. Pi. Okay, from 2 to 5. Let's get this straightened out. So let's see. 5 minus y, distribute in the minus sign, plus 2. 5 plus 2 is 7. So this will be 7 minus y squared minus 4, all of that, dy. Okay, like that. We can square this, so let's do that. Let's see, 7 squared is 49. Alright, so 49. Let's do it like this. I apologize. Okay, so now 49. Now don't you do minus y squared. You're going to You'll multiply those two together, 7y, and then you're going to double that. Just remember you do that. So now this makes this 14y. Okay. And then remember, a negative times a negative is a positive. Do not put a negative here. Y squared, and then minus 4, and all of that. Well, I could have just used parentheses. Okay. dy. 49 minus 4 is 45, so I'm going to erase this and put 45. I don't need that 4 on anymore. Alright. Now, all of that times dy. Okay. If you have a graphing calculator, you can go ahead and put this in there and figure out what this is, but I'm going to do it by hand. I always do. Maybe that's just the old school coming out of me. But old school learns a lot, so. Alright, now equals, now pi. We're going to probably have to flip this now. And, okay, this is going to be lengthy. So I probably am going to have to, let's just go ahead and flip the board. I think I have it written down here. Yeah, I do. Alright. So let's do that. I know it's going to be lengthy here. Alright, here we go. Flip this over. I'm just going to rewrite the problem on the other side of the board. Alright, now, let's see. We were putting that pi up here. Alright, from 2 to 5. Okay. Now I'm saying that was 45 minus 14y, okay, plus y squared dy. Good. Let's go back again and look at that. If you can just get to this is x, this is 5, this is 5. If you get where you can do that, you can master a lot of other things that are similar to this. A lot of other things. Okay, just kind of keep that in mind. This is 5, this is x, this is 5 minus x. X is y minus 2, 5 minus y minus 2 squared. We know what this distance is. We know it's bounded by x equals 3, and it's going around x equals 5. So 3 minus 5 is 2. There it is. Get where you can do that. And I just substituted this into that x there is all I did. Distributed the negative, got this, squared the 2 and got the 4. Okay, like that. Alright, here we go. We're going to just put that back up again. And we're down to this now. Alright, now see, if you can get that, that becomes really, really easy. Now let's integrate. So here we go. Equals pi times, okay, big long answer here, 45y minus 14y squared. Remember, we're dividing that by 2, plus y cubed over 3. Alright, that goes like that. 14 over 2 is 7, so I'm just going to make that a 7y squared. So this is all 7y squared. Okay, now we're going from 2 to 5. Be nice if that were a 0, but it's not. So we got a long problem here. Okay, it makes for a long answer. That's okay. Pi. Alright, now on your calculator you're not going to probably have a y, but you can still put the x in and still get the same result. Okay. Alright, there you go. So let's see, 45 times 5 minus 7 times 5 squared plus 5 cubed over 3 minus sign. Now look, parentheses. Immediately do that. Alright, so let's see. 45 times 2 now minus 7 times 2 squared plus 2 cubed over 3. I don't think we have to worry about this, whether we need a common denominator or not. I think we're going to be alright. Just remember, put this in parentheses, okay? Now let's go. Now this is equal to pi. Alright, 45 times 5 is 225, I do believe it is. 20, 21, 22, 225. Alright, 7 times 5 squared is 7 times 25. And I think that is 175. So 175. Let's just, 5 cubed is 125. Now I'm just going to go ahead and distribute the negative sign each time. 45 times 2 is 90. Negative times a negative is plus. Be very careful here. Don't get this far and miss it. Alright, so negative times a negative is positive. 2 squared is 4. 7 times 4 is 28. Alright, minus sign here. So just change your signs. Okay, minus, plus, minus. So minus 2 cubed is 8. 8 over 3. Alright, that's it. And then we just kind of put all of this together. Well, let's see what we get if we do that. Alright, 225 minus 175. Okay, that's 50. Minus, okay, plus rather. Okay, all of this is 50, I believe. Alright, let's do this. 125 minus 8. 15 minus 8 is 7. So 117. So plus 117 over 3. And 3 will go into 117. Good. Alright, I got these two. So these two and these two. Alright, that works good. And then minus 90 plus 28. So minus 90 plus 28. 10 minus 8 is 2. And 8 minus 2 is 6. So negative 62. So negative 62. Woo. Alright. Okay, let's see what we get here. 117 divided by 3. Let's get that real quick. Divided by 3. 3 threes are 9 rather. 3 threes are 9. 10, 11. 3 nines are 27. So this is 39 right here. So this is pi 50 plus 39 minus 62. Alright, here we go. This is going to work out fine. Alright, erase this. Alright, I do things the old school way. That's just that's how I do it. It's alright. Alright, so this equal to, alright, so this will be 9. 5 plus 3 is 8. 89. Right? 0, 9, okay. Yeah, 89. So 89 minus 62. 89 minus 62. 7. And 8 minus 6 is 2. That should have been easy. Alright, so 27. Don't forget you got a pi sitting out there. Pi. Alright. Cubic units. Alright, there it is. Whew. Cubic, because remember, this is a volume right here. The area being generated and then putting that dy gives it an extra dimension. Okay. Alright, so 27 pi cubic units is what we got here. And I believe when I checked on my calculator, that's what I got before I put this up there. Alright, so the key to getting this is right here from the start. This is 5, this is x, this long radius is 5 minus x, but x is y minus 2. Okay, so we put that together and square that, and then this radius here is 2. Alright, so 2 squared is 4. Getting all that together, we finally come up, and of course you can integrate from there, and you come up with 27 pi cubic units. Whew. A lot of problem in it. I knew it would be. I worked it out. I saw how much work was involved in this, and so yeah, it's pretty satisfying to be able to do this. Just think what you're doing though. Each time you do one of these, do you have are you going to have a hole, or are you not? If you have a hole, it's going to be big radius squared minus little radius squared. Okay. If you don't have a hole, then it's just going to be some quantity squared. Okay, like that. Dx, dy, depending on what you're doing. Okay. All right, that's all I have for today. This is going to be my last video for today. I've got a few other things I've got to do, and so this is KP the Math G. Please, if you will, hit that subscribe button. I get encouraged when I see more and more subscribers. But again, if you don't, this is important here, that you understand how to do this. I just encourage you to hit that subscribe button and hit that like button if you like the video. If you have a comment that you would like to make, please make a comment. If you have something that you feel like is easier than this, fine, please tell me. But again, as I always say in all my videos, please be correct. And if you are correct, I will get up here and put your problem up here an easier way. Because we do like an easier way, but we want the best way also. We want the way that's going to help us understand this. I hope that this has been beneficial to you. I know every time I do it, it helps me a whole lot too. Keeps my mind sharp. And at 63 years old, I like to keep my mind sharp. Okay. All right. Well, anyway, KP the Math G signing off. Have a great day.